link state routing protocols assign a cost to all of the links, and we're just accumulating that cost. Now, the way that OSPF derives the cost is based on this formula right here. Reference bandwidth divided by interface bandwidth. And the default reference bandwidth that we see on iOS gear, I want to be specific about that because it changes if you're on other gear from Cisco. Like the Nexus product line has a different reference bandwidth. It's actually 10 gigs. The reference bandwidth here is important because what it does is it sets the numerator of this fraction. And so if we choose a higher number here, we're downscaling the result of this fraction. And that's good to do because the problem is if you divide anything that's greater than 100 megabits per second into this, let's say your interface bandwidth is 500 megs or a gig or 10 gig. If your reference bandwidth is 100 megabits per second, then your cost is going to be 1. This is really problematic. By the way, it's good to know that T1 speed is 64, a cost is 64. Ethernet is 10. But we may, in fact, really need to manipulate that reference bandwidth here. You could do that, and that's more effective for, in my opinion, than manually setting the cost, which you can do. Go to the interface level IP OSPF cost. That'll work. You also want to make sure that your bandwidth is accurate. So the problem that we see is that T1 links get a default bandwidth of 1.544 kilobits per second, or 1.544 megabits per second. You do want to make sure that your bandwidth parameter is accurately reflecting the effective throughput that you are getting. But if you do want to change the cost directly, you can do IP OSPF cost at interface level, or you can do this auto cost reference bandwidth. And it takes the input in megabits per second. So if we were going here, I would firstly, this would be a meaningful thing. This would be a very significant thing to us. And I'll do a show IP OSPF, and we'll look for a reference bandwidth here. Okay, we'll look for a reference bandwidth and show IP OSPF output. It's in there. I just got to find it. There we go. Probably saying, Dan, what's going on? All right, so reference bandwidth is 100 megabits per second. So if I want to change that, we can. And actually, let's look at an adjacent router. I want to use R3. And I want to look at some routes. Show IP OSPF, or show IP route OSPF. And we'll look at some of the routes that exist right now on R1. And this is a good example right here. Okay. So we'll look at the 10.1.1.16. If I choose to manipulate this, I'll say reference, it's actually auto cost, reference bandwidth. And then I put in the value in megabits per second. Really a good value. Now, this is not the sort of thing you change on a whim, but I like 10 gig or even 40 gig. I'm going to do 40 gig, and it tells us don't do this just on your own local router. It doesn't break neighborships, by the way. Now let's see. I'm going to do that same. Now the cost, what was the cost? Can you tell me the cost? Cost was 2. Administrative distance 110, which we're not manipulating here, it cost of 2. Do that command again, and we get really the same cost, but there is a subtle difference that is going on here, and that is something worth speaking to. Previously, I was load balancing there. Now, not so much. That's because R1's cost is really high, but R2 had an equal cost, and now we're just using R2. So I'll scroll down. We've got to change this consistently. we are impacted by that. So I'm just going to copy that. We're going to go to R2. Redo that show command. Give it a little bit more time. And now we're getting a cost of 41. Great. So the links that we're crossing, and we're just crossing 2 fast Ethernet links. Actually, I think one of these, one of them is gigabit. And actually, probably both are gigabit. Yeah, both are gigabit. That said, we're getting a more tangible cost going across these links, which is really important. So, anyways, now you've seen how to manipulate your auto cost reference bandwidth. Do this on all of your routers. And again, show IP OSPF will display to you your reference bandwidth as manipulated. And doing this in the modern world is now more important because we are seeing 10 gig links and 40 gig links, 100 gig. That's the sort of thing that it is going to be the staple of connectivity inside of our autonomous system. And we have to make sure that OSPF is properly prepared for those high-speed links.